This is a home chemistry experiment demonstrating electrochemistry. Be creating an impressed current corrosion cell where an electrical current's flow is controlled between a cathode and anode through an electrolyte being water. This is a multimeter. It will measure DC voltage between the cathode and the anode and the electrolyte. This is a copper sulfate half cell, which has a copper rod in it and a copper sulfate in there. This will measure the potential between the electrolyte and the structure. The negative lead up to copper sulfate. This is the cathode. It is a piece of fusion bonded epoxy on a pipe. There are two coating flaws in it called holidays that are bare pipe. Touch the multimeter to the end of the wire coming off of the cathode. You see that it reads 0.52 negative volts. This is the anode. It's just a piece of aluminum square tubing. You hook this up to the multimeter, it reads negative 0.66. Then you'll hook up a 12-volt charger to the leads, positive to the anode, negative to the cathode. Turn power on. Coming from this, you will start to see bubbles will form on the holidays in the coating. The bubbles that you see forming is the H2O splitting into negative hydroxide atoms and positive hydrogen atoms. This is caused by the difference in voltage between the cathode and the anode through the electrolyte. What you cannot see is that the negatively charged electrons are flowing from the anode, being aluminum, into the cathode, being the gas pipe. With the negative electrons flowing to the cathode, this will cause ionization of the anode, or for the anode to corrode instead of the cathode. Therefore, you are stopping the corrosion of the cathode and causing corrosion of the anode.